yesterday we talked about finding how much space was inside something, just like these figures on the POD we found. Volume. How much space could fit inside my package or my rectangular prism or any type of box that I have. But what if I wanted to know how much wrapping paper I needed to cover the outside of my box? Take a second and talk to your partner about a strategy you think I can use to find how much wrapping paper I would need to cover my box.
Well,
So how much wrapping paper do I need to cover my box? So I can wrap the whole thing wrapping paper. The outside, right? Like if I was wrapping the present. What big strategy do you think I need? Oh, you guys come up with a strategy.
I like that. I feel like the area and then half my one is I would really
Measure what again? So like the width, so measure how much I could cover for one part. And then what? Oh, I need that part too. All right, 5 seconds, 4, 3, 2, and 1. I want to hear some of your suggestions about how you think I can figure out how much wrapping paper I need to cover my box. Shayla?
First, we can like measure the box.
What do I want to measure about my box?
Like you want to first measure the top and like
Right here?
not the top, but like the
Right here.
yeah.
Okay, so like the length?
Yeah.
Okay. So just start by measuring the length. That might be the best idea. Okay, good suggestion. So we'll start with length. Shay, you have another suggestion? You think I might measure the perimeter? Okay. So that goes with Shayla's idea about measuring the length. Maybe I can measure the perimeter of the box. Okay. Lenny? Okay, so you think that I need a height too. What do you mean when you say layers? Layers of wrapping paper?
Wait, are we wrapping the box?
Yeah, we're trying to wrap my box. You gonna keep thinking about it? All right. But I do like your idea of we need to know the height. Kyla? You think I need to do some multiplication? Okay. Javon? You think I need some base times height? I like that suggestion. Base times height of what? When you're looking at my box, what do you find in base times height of? Can you tell me what you're thinking of? Show me. Base times height. Okay, so Javon thinks that I need base times height for this part right here, the top part. And what's that going to give me? Oh, for all of them. So what do you mean all the parts? Show me. So you think I need it for here? Okay, so Javon thinks that I need to do base times height, which gives me what? The area. All right. Javon thinks I need to do base times height for all parts of my box. He thinks I need to do it for the front, the top, and the sides. But if I hold the box like this, can you see all the parts? No. So that might be difficult, right? Well, wrapping paper, to find out how much I need to cover everything, remember we talked about covering, it does talk about area. When we want to cover something, we're talking about area. So there's a special name for that when we're dealing with 3D figures. Does anyone know what it's called? Special type of area? It's called surface area. And surface area is the number of units, square units, that we need to cover the outside of a figure. So here we see Javon's suggestion about finding the length times the width, or the base and the height of each part of our box, each side, right? But it's kind of hard to tell when you just look at it like this, right? So, does it help if we look at it like this? Take a second to talk to your partner about whether you think this is helpful or not, and why. So how will this help you find the area, the surface area of your box, if you look at it this way? What do you think? It's helpful? Yeah. Why? This looks kind of funny to you. So you're thinking if I break it into this one long one and then find these two little ones? All right, 5 seconds, 4, 3, 2, and 1. I want to hear, do you think this is helpful or not? Nevaeh. So you think it's helpful because now I can see all of the squares or rectangles of my box. So like if this was my box before, I can open it and here's my top, and now it's a flat rectangle. And my sides become flat rectangles. And everything opens up to become one flat rectangle so you can see the area. I agree. How about you, Shayla? What are you thinking?
I said yes because you can like measure the whole downwards triangle. Rectangle.
Okay, so you're thinking I start here and measure all the way down to here to get the length?
Yes.
Okay.
And then just do the two sides separately.
Okay, so you think I can like decompose it or break it down into one big long rectangle, find its area, and then find these two? And then what do I do once I have this and this? Add them together, and I'll get the whole area. Good suggestion. So when I open something up like this, if I open a box or a prism and I kind of have a 2D drawing of it, it's called a net. So here's my box, and this is what my net looks like. So just like we had a package like this, this was my 3D figure of a rectangular prism, and when I opened it up and had a flat drawing, a 2D drawing of it, I had a net. So let's try Nevaeh and Shayla's strategy to find the surface area. Before, Javon suggested that we get the area of each rectangle and add it all together. And Nevaeh suggested that it's actually easier to see all the rectangles with our net. So we're going to try to find the surface area of my box. So here's my box. And the front of my box is 10 inches. The width of my box is 6 inches, and it's 4 inches high. And here's the net. So just like when I opened it like this, it's the same thing. So here's my box, and I start opening it up. Here's the top. There's the top. Here's the back, falls down. Then I have the end and the end. The front falls out, and then the bottom. So I can look at it just like this. So let's start solving for the area of each rectangle, like Javon suggested earlier. So who wants to help me out with how I can find some of the areas for my rectangles of my box? Connor, go ahead. Which one are you going to do? So you can pick a rectangle. You want to start with the front, the top, the end?
Just the top.
You want to start with the top. All right, and what'd you get for your area?
60.
60 what?
Inches.
Inches. When we talk about area, we talk about square inches, right? So when we have area, we did length times width. You did 10 times 6, so we have 2 dimensions, so we need square inches. Go ahead, Preston.
The front.
Front. What are you thinking?
40 square inches.
40 square inches. Kyla?
The end.
Okay. Which end? This one?
Mm-hmm.
And what are you thinking?
24 square inches.
24 square inches. And how'd you get that? 6 times 4. I like it. Now what about this bottom, the back, and the end? Because I don't see any dimensions labeled on those. So my question is, how do I know? All right, Lenny. So which one are you talking about?
The back.
The back. All right.
The back is the same as the front.
The back is the same as the front. Okay. So what do you think the area is? 40 inches squared. How do you see that? How do you see that the front and the back are the same?
Oh,
Go ahead.
because they're both same size and
So you think they're both the same size from looking at it? Like that's your best judgment about you think they're the same size? All right, Kayla.
when you fold up the front, you can see that it overshadows the back, and then you can see that they're the same size.
Okay, so Kayla sees that when I have the front and I have the back folded up. So let's just say I just have the front and the back folded up, that they look like this. And she can see that it kind of like shadows it. You can kind of see the exact thing. Shayla, what were you going to add? Okay. Connor, did you want to add something to that? Okay, you guys are ready for the next one? All right. So good thinking that we think it's about the same because when we fold them up on both sides, we want to make a box across the top. What about our bottom or our end? Who can help me out with those? All right, John. The bottom is the same as the top. So what do you think our area is? 60 inches squared. Who can explain to me why Javon thinks that they have the same area? Nevaeh? Right, the top and the bottom are a perfect match. So when I fold this up, I top and bottom. So I can even see if I just see a picture like this and I know the area of the top, can I figure out the area of the bottom? What do you think, Shayla? Yeah, you're right. So what about my other end? Because this one's over here by itself and I don't really have any dimensions for it. And I can't see it in my picture, so I'm not sure what to do. Shay? 24 what? Inches squared. How'd you figure that out? Same as the other end on this side, right? Because when we fold them up, we see the same. So now I see that I have, Shay just told me that I have two ends that are 24 square inches. We said that I have a top that's 60 inches squared and a bottom that's 60 inches squared. And we have a front that is 40 inches squared and a back that is 40 inches squared. But I wanted to know how much wrapping paper I need for the whole thing. This is all separate. If I want to cover just the top, I can do 60 inches, but what do I do with all of these? If I want to know how much wrapping paper I need for the whole thing. What can I do with all these numbers? All right, Nevaeh, what do you think? Add them all up is your first suggestion. Okay, what's your next suggestion? All right, so Nevaeh thinks that I need to add all of these up so I can find the total area. And her suggestion was, since there's two of these, I can do 24 plus 24 and get 48. 60 plus 60 is 120, and 40 plus 40 is 80. And then we added all these up, and what'd you get? 248. 248 square inches, because we're solving for area. Right. Mary, did you have something you want to add? Oh, you were going to say 248 too? All right. So once I find the area of each of my individual rectangles, who can remind me what I do? Once I have the area of each of my rectangles, what do I do with all those numbers? So I found that this top was 60, then I found 40, so I have 24, 24, 60, 60, 40, 40. What do I do with all of those? How did I get to 248? I added them, right. So to find our total surface area, what do we do? Right, we count all of the areas up for all of our rectangles. To get, right, so our surface area would be 248. So now your job, you work at the post office, and you have been noticing that a lot of people have been coming in and they need a package that fits 24 centimeter cubes. So they need a volume of 24 centimeter cubes, right? So they need to make sure that their package is going to fit 24 cubic centimeters. But we want to know, is there more than one way our package can look? Can we have different dimensions? Thinking back to our POD, these look different, but they both had a volume of 8. So this time, we always need a volume of 24, but we can have different lengths, widths, and heights. And then we're going to solve for surface area. So I'm going to pass out the worksheet, and then we're going to do the first one together. You're going to have a chart just like mine on the board. All right. 5 seconds. 4, 3, 2, and 1. So you're going to get little cubes, little centimeter cubes, to build your package. So you have these cubic centimeters, and you need to build your package. Now, who can remind me what volume I'm looking for? 24, right. So my volume always needs to be 24. So my volume always needs to be 24. Now let's look at my shape, and let's talk about what we think the length is. In case you can't see them up here, I'll let you know what each side is. All right, so let's talk about the length. What do you think the length is of our figure? Connor. So you're going to call 4 your length. Okay. So in your chart, we're going to identify the length as 4, because Connor saw that there were 4 cubes along the bottom. What about my width? Lenny? 3? Column 3 my width? Okay. I like it. And what about the height? Reggie? 2. Does it matter if I put these in a different order?
No. Wait. No.
What do you think?
Oh, no.
If I mix these up?
No.
No, right? Because we're still multiplying. When I multiply, does it matter if I do 4 times 3 or 3 times 4?
No.
Right, I get the same answer. So, if these are my dimensions, how can I get the volume? To double check. Okay. Multiply. Length times width times height. Good. So what would I do in this case? Kyla?
4 times 3 times
4 times 3 times 2, and what do I get?
4.
24. Just what we're looking for. So now I need to know the surface area. So I use 24 cubes to find my volume. So a suggestion I have for you is when you're solving, start by counting out 24 cubes because that's all you have to use. But how can I find the surface area of this? Where should I start? All right, Cheyenne, you think I need to start with the top. What should I know about the top? The area, how many cubes there are. Right. So what about my top? Shayla, go ahead.
If you find out what the area of the top is, you have to multiply it by 2.
Okay, so you think I need to find out the area of the top and multiply it by 2. Why am I multiplying by 2?
Because in order for you guys to find out what 12 times the times 16.
Okay, so you're thinking if I have 12 times 2, I get 24. So you're saying that my area up here is 12. Who can explain why else Shayla might be thinking that I have? She said the area up here is 12, but why would I need 2 12s? Shay?
Because your height is 2.
My height is 2. Good suggestion. But we said surface area was adding. Go ahead, Connor.
Because in order to make 24, you need to have 2 12s because 12 plus 12 is 24.
All right, so you're telling me about volume. So you're telling me I found the area of one slice is 12, and then I multiply by a height of 2, right? But now I'm talking about surface area. So we already checked, we got a volume of 24. I see what you guys are thinking. We need a 12 here, and then we have 2 slices, so we got 24. But now surface area. Remember we talked about my box and how we needed to know how much wrapping paper for my box?
So basically, we're just going to do another net strategy before.
I like it. Another net strategy you're thinking. So what if I needed to know how much wrapping paper for this box that I just made? What would I do? Shayla found that the area up here is 12. But that's only the area for the top. So now I have enough wrapping paper just for the top. What about the rest of my box? Take a second, talk to your partner. Think about wrapping paper. What if I want to wrap this? What am I going to do? Surface area. Good. That would help. All right, 5 seconds, 4, 3, 2, and 1. So I would like to know, what do I do for surface area? I have the top, but that's only enough wrapping paper to cover the top. Go ahead, Shay. I add each side together. What do I need to know about each side to add it together? Am I solving for the perimeter of each side, the area? What am I doing? The area, right. I need the area of each side. So I know that I have 12 on the top. So what about the bottom? Because I can't see the bottom.
It's 12.
Nevaeh, what do you think? It's 12, right? Just like we talked about before, top mirrors the bottom. So far we have 12 plus 12. So what else do I need to know? Because right now I only have enough wrapping paper for the top and the bottom. The sides. Preston, what are you thinking?
Where the 4 is, it should be an 8 because of the 2 stack. Cause I'm in
I see what you're saying. So you're saying that the area right here is 8 because you see that there's 4 along the bottom and it goes 2 up. So 1, 2, 3, 4, 5, 6, 7, 8.
yeah, there's 4 on the top and the bottom.
So you see 4 right here and 4 right here, so this whole side would be 8. I like it. So the front side is 8. What about the back? Because I can't see that either. Connor.
It's basically the same exact thing.
It's basically the same exact thing, right? Because it's just on the other side. Am I missing any parts of my box?
Yes.
Or do I have it all?
It's
What am I missing?
that part.
Right here?
No, the other side.
Over here?
Yeah.
Oh, I'm missing both of those. All right. So what is the area of those sides?
6.
6. Is it going to be the same for both?
Yeah.
Yes.
All right. So what?
It's 52.
So I add them all up, right? Because I found the area of one side, the other side, all the sides, and to find the area of the whole thing, what do I do with them? Add them up. And what do I get?
Oh,
Reggie?
Yeah. I got the
I got it.
52. I like it. And we're working with centimeter cubes. So it's going to be 52 square centimeters. So our volume was 24 cubic centimeters, like Nevaeh said. But when we do area, we just have 2 dimensions. So you can copy this one down in the first row of your chart. And your job is to find out as many boxes as you can that still have a volume, but they're going to have different surface areas. When you're adding together your surface area, make sure you have 12 things that you're adding together. 12 factors because 6 factors that you're adding together. Because you have the top and the bottom, the front and the back, and the 2 sides. Okay? So we're going to pass out the cubes for you to work with, and you're going to work with your partner. Yeah, you can help. So 1 per partner. So I would start by taking out 24 cubes because that's all you have to work with. So count 24 cubes. Well, I like that idea. Try building it. Okay. 6 times 8, what is that? Right. So what could I multiply by 6? 4. I like it. So you're thinking 6. Good, Shay. So you're thinking 1. Why would it be 1? Right. So now let's build it so we can find the surface area. You need 24 cubes. Maybe you and Shay can work together. So this would be. That these would connect. You like put them together like blocks. Yeah, you just push them together. And then you can build them up. So I just. What's yours looking like? Yeah. So you said the one you did up. So you used 24 cubes. So you took our shape and stood it up. So is our surface area? Oh. So what's your length? So what do you think? 2. All right. And what is your height? 4 and your width? Right. So what's my volume? Okay. But I see 2, 3, and 4 gives me 24, and I see 4, 3, and 2 gives me 24.
Surface area.
And then you width is 5.
So let's see. So let's start. Let's start by finding the area of our first rectangle. You want to do that side? Okay. 12.